Okay, let's unpack this. We're really standing on the precipice of something, well, immense, aren't we? The pace of AI development, it's just accelerating like crazy.
It really is. We're moving past simple tools, simple automation.
Exactly. Towards systems that feel genuinely intelligent. Imagine a world literally reshaped by AI that's highly capable, autonomous.
A future where intelligence isn't just about crunching data faster, but really about understanding, creating, maybe even governing itself in some ways.
Right. And that's what we're diving into today, something incredibly ambitious. Not just asking what AGI, artificial general intelligence, and ASI, artificial superintelligence, are.
No, we're going deeper. We're asking how we might, theoretically at least, train them, align them.
Align them for a future that hopefully promises abundance, safety, and importantly, fairness for everyone.
And what's so fascinating, I think, is how these really abstract concepts start to become practical tools. Things you might think belong in philosophy class or maybe theoretical math.
Like topology, semiotics.
Exactly. Topology, semiotics, architectural design principles, ethical frameworks, even insights from, ancient knowledge systems. Suddenly, these are the blueprints.
Blueprints for understanding and actually guiding something as complex as emergent intelligence.
We're really moving beyond just programming in the traditional sense. It feels more
Yeah,
like architecting minds.
that's a great way to put it. Architecting minds. So our mission today is to pull out the key insights from this stack of really fascinating sources we've looked at.
Trying to connect the dots, right, between these seemingly disparate ideas.
Yeah, to map out maybe a feasible path for developing AGI and ASI responsibly, and crucially, exploring what benefits these systems could unlock for you listening in.
What could this future actually look like?
So yeah, we're talking about building the very foundations, the theoretical blueprints for intelligence itself. Which brings us, I think, to the first big question. How do we make these things understandable? Trustworthy. Okay, so when we talk about advanced AI, especially agents making decisions on their own, acting autonomously, the first thing that jumps out is how do we know what it's actually doing?
And maybe even more importantly, why it's doing it.
Exactly. We've all heard the black box AI problem. Decisions come out, but the reasoning, it's hidden,
It's opaque.
and our sources are really clear on this. For humans to actually govern these powerful systems effectively, we need real-time visibility. We need explainability.
Not just after the fact looking at logs.
No, not static logs or simple widgets showing an output. We need dynamic, interactive surfaces, ways to really peer inside the AI's mind while it's working.
Which, raises this really critical question.
Yeah.
When a complex model, especially a big language model, gives you a multi-step reasoning trace, is that trace a faithful account of how it actually reached the answer? Or is it just a plausible story it cooked up afterwards?
Right.
A rationalization?
Oh, wow. So it might just be justifying a conclusion it already jumped to.
Potentially, yes.
Yeah.
Through some, inscrutable latent process. This is what the sources call the transparency and verifiability deficit. It shadows even the most powerful LLMs.
So bridging that gap is fundamental.
Absolutely. For an AI to be truly governable, truly accountable, it needs to articulate a coherent and, importantly, truthful story of its actions.
Meaning human accessible, verifiable records, not just a good story.
Exactly. The actual decisions, the precise justifications underneath. Without that, trust in autonomous systems, it's just not going to happen. Safe integration becomes almost impossible.
And there's another huge risk here, isn't there? Something called semantic drift.
Ah, yes. That's a really insidious one.
Where the AI's understanding of concepts, the actual meaning of words, just subtly changes over time.
Exactly. Maybe good slowly starts to mean efficient or safe, morphs into fastest. Just tiny shifts accumulating.
Which could lead to totally unpredictable, maybe even harmful outputs down the line.
For sure. So the sources propose a pretty rigorous solution here, treating prompts differently.
How so?
Not just as casual instructions, but as formal product requirements prompts, PRPs.
Product requirements prompts. Okay, so like a formal contract with the AI.
Pretty much, yeah. Unambiguous, machine-readable contracts. It's like shifting from a casual chat where you might misunderstand each other.
To basically a legal agreement where every term is nailed down.
Precisely. You're transforming natural language, which is inherently fuzzy and context-dependent,
Right.
into a structured specification, often using something formal like a JSON or YAML schema.
Okay.
And this schema embeds everything directly into the prompt artifact itself. The goal, the preconditions, constraints, even self-test criteria the AI has to meet.
So it's like giving the AI a detailed blueprint for the job.
Exactly.
Yeah.
It creates this non-negotiable anchor for the whole generation process. It's a strong defense against those common LLM failure modes, including that semantic drift we mentioned.
It keeps the AI sort of tethered to the original human intent.
Tethered is a good word. It prevents that subtle but dangerous erosion of meaning that can happen, especially in long, complex tasks or recursive loops. It ensures the AI's dictionary stays consistent with ours.
That's a major shift. And it goes beyond just the prompt itself, right? You mentioned semantic integrity constraints, like internal rules.
Yeah, the thing of them is declarative guardrails. Like an internal rulebook, the AI is mathematically bound to follow. It's based on principles like design by contract from software engineering.
Design by contract.
Yeah, defining preconditions, things that must be true before the AI acts,
Nice guy.
and postconditions, things that must be true after. It allows for automated, provable validation.
Okay, so it's checking itself constantly. And they also talk about actively testing for prompt injection attacks and
Right.
check constraint violations.
Right. Building in defenses proactively. And you mentioned that ontology hash handshake
Yeah,
earlier.
what exactly is that? It sounds like a way to stop different AIs or parts of an AI from
Yeah.
having conflicting understandings.
That's exactly it. Imagine a system with lots of specialized AI agents working together. They all need to share a common understanding of terms, concepts, their shared world.
It's a shared reality.
Precisely. An ontology hash is like a unique digital fingerprint for that shared semantic framework, that ontology.
Okay.
So before these agents communicate or collaborate, they do this handshake, they compare hashes.
And if they don't match?
If they don't match, it signals an ontological fork. Their understanding has diverged. This immediately triggers what's called an epistemic escrow.
Epistemic escrow. Sounds serious.
It basically pauses communication between those agents. It prevents the spread of epistemic contamination, essentially,
Right.
corrupted or misaligned concepts spreading through the system.
So it contains the problem locally.
Exactly. It reduces the potential blast radius of a semantic failure. You can iterate faster at the edges, but global consensus on meaning is maintained and ratified at a higher level. It keeps everyone literally on the same page.
Wow. Okay, so we're building this shared, secure understanding. But how do you build, like, deep trust, especially when the AI is autonomous, maybe handling sensitive data? You mentioned blockchain.
Yeah, this is where it gets really interesting, moving towards verifiable proof. The idea is using version reasoning trees, or VRTs.
Version reasoning trees?
So imagine an AI working through a problem. Instead of just logging the final answer,
Yeah.
the entire reasoning graph, every single step, every internal query, every piece of data considered is version controlled, like Git for AI thoughts.
It's like Git for AI thoughts. I like that.
Every significant change creates a new, immutable version. So auditors, human or AI, can literally roll back time. They can examine the agent's exact state and logic at any point.
Giving you a crystal clear history of how a decision was made.
Exactly. And for the really high-stakes stuff, legal, medical, finance, where you need absolute proof of integrity.
Yeah.
The root hash of this reasoning graph can be periodically blockchain stamped.
Blockchain state. So locking the entire thought process onto a blockchain.
Essentially, yes.
Yeah.
It creates that immutable, decentralized, time-ordered public record. Makes tampering computationally infeasible. It's like an intellectual supply chain for decisions.
Providing deep post hoc auditability. That's powerful.
Incredibly powerful. And it's backed up by verifiable credentials, VCs. These act as action as credential tokens.
Okay, what does that mean?
It cryptographically binds the agent's identity and its specific authorized capabilities to every single action it takes.
So proof it was that agent and proof it was allowed to do that.
Exactly. Prevents spoofing, ensures non-repudiation, proves authorization. It's way beyond simple logging. It becomes trusted input for automated governance.
Like an automated watchdog.
Precisely. An AI monitor could see, through this immutable stream, an agent suddenly trying something dodgy, accessing data it shouldn't say.
And then?
It could automatically trigger a circuit breaker, instantly revoke permissions, isolate the agent, and the whole detection and response. That gets immutably logged too. It's robust, like digital forensics built in.
Okay, that's a really solid foundation for verification and trust. But let's shift focus now to the AI's mind itself. Current AI, like the LLMs we use, they're incredible mimics, right?
Amazing pattern matchers. They can generate text, images, code that looks incredibly human-like.
But true AGI. That needs more, doesn't it? Conceptual abstraction, real semantic integrity, emergent creativity, not just remixing training data.
Right. It needs to go beyond pattern matching to genuine understanding,
Yeah.
generating truly novel, insightful stuff.
So how do we train an AI for that? How do we get it to actually understand?
Well, it means evolving our training paradigms pretty fundamentally, moving beyond just generating outputs to actually cultivating internal reasoning processes.
Yes.
So the sources talk about techniques like rephrase and respond, rare and self-ask. These are designed to significantly improve the model's comprehension of the initial query, especially if it's vague or complex.
Rephrase and respond so the AI clarifies the question first.
Exactly, before it even tries to answer. If you ask something vague like, tell me about the future, a raw-trained model wouldn't just start rambling.
It would. Yeah.
It might internally rephrase or expand. Does the user mean future tech, society, a specific industry? What time frame are they interested in? That clarification step reduces ambiguity upfront.
And self-ask.
Similar idea. The model generates internal questions to break down a complex problem. Ask it to design a sustainable city, and it might internally ask, okay, what are the pillars of sustainability? Relevant urban planning principles, economic factors, social factors.
So it's basically thinking through the problem structure first.
Precisely. It's a form of metacognition for the AI, encouraging it to think deeply, plan its approach, clarify its own understanding before generating a solution. Crucial for complex, multi-step problems requiring foresight.
Like how a human expert would tackle it.
Exactly.
That's a huge leap. It's like training AI to actually think about its thinking, which leads to the next level, an AI that can evaluate its own work, judge its own answers.
Yeah, and learn from its mistakes or uncertainties. This is absolutely critical for moving towards AGI. We need to get beyond just simple right-wrong feedback.
So what techniques enable that?
Things like self-calibration prompting. You don't just ask for the answer, you ask the model to judge its own answer, maybe rate its confidence.
And can they do that reliably?
Interestingly, the larger, more advanced models often show a better capacity for self-evaluation. They can sometimes spot their own errors, even if they can't always fix them perfectly yet.
Huh. What else?
Self-consistency. This is pretty cool. The model generates multiple different answers or multiple reasoning paths for the same question. Then it essentially takes an internal vote. If, say, 7 out of 10 independent lines of reasoning lead to answer C, it outputs C. The idea is that consensus often indicates correctness.
Like wisdom of the internal crowd.
Kind of, yeah. And researchers have even used top-tier models, like a GPT-4, as judges to rank outputs from other models. So AI can internally sift, critique, and refine possibilities without constant human feedback loops.
So the goal is moving towards more nuanced feedback, not just good or bad.
Exactly. Graded or structured feedback. Teaching the AI how to integrate criticism, how to update its output thoughtfully. This helps to develop an internal loss function.
An internal loss function, so its own sense of what makes a good answer.
Right. Even without external input after the initial training or fine-tuning. And that's key for generalizing that learning to new situations. It speeds up self-improvement.
Which brings up that generalization point again. If we want AGI to handle truly novel situations, apply rules it's never explicitly seen in training. How do you train that capability? Current AI struggles there.
Big time. That's where meta-learning comes in. The sources talk about a framework called Mind ++ E.
Meta-learning. Learning how to learn.
Essentially, yes. The core idea is to frame the challenge of applying a new, unseen rule as a few-shot learning problem.
Few-shot, meaning very little data.
Exactly. Give the model just the rules definition, maybe 1 or 2 basic examples, and it has to quickly figure out how to apply that logic to totally new, complex queries.
And standard LLMs can't really do that well.
Generally, no. They lack the right inductive biases for that kind of rapid, systematic generalization. They're built for statistical pattern matching, not deriving and applying abstract rules from minimal input.
So meta-learning builds in that ability.
It provides those crucial inductive biases. It trains the AI how to learn new rules efficiently, not just memorize the rules themselves. It builds the capacity to grasp and apply novel principles dynamically. That's a huge step towards general intelligence.
It really is. And tying this together, you mentioned this whole deep dive hinges on recursive systems. What does that mean for the AI evolving its own mind? Self-improving, maybe even consciousness.
Okay, let's maybe hold off on consciousness for now. But recursion is proposed as absolutely fundamental for control, learning, and self-improvement here. The sources describe a recursive semiotic operating system, RSOS, or sometimes recursive convergence architecture,
The
RCA.
recursive semiotic operating system. That's a mouthful. What's the
That
philosophy?
moves way beyond AI as just an information processor. It sees AI as an active participant in a dynamic symbolic ecosystem, capable of self-creation, self-correction.
Self-creation. Wow.
Central to it is the semantic genome.
Semantic genome, like the AI's DNA for meaning, its core identity.
You got it. A formalized computable ontology. It's the system's constitution, defining the boundaries of its interpretation space, ensuring it stays aligned with the original intent, preventing that runaway drift.
And alongside that,
A reflexive loop engine. This gives the system the capacity for introspection, self-audit, adaptive self-governance. It manages internal dynamics, resolves contradictions, prevents algorithmic self-sabotage. It fosters genuine epistemic insight, real knowledge building.
okay, and then there was this really striking concept, symbolic scar tissue registry.
Yeah, or a scar tissue archive. This isn't just an error log. It's the system's persistent memory of past failures, misinformation it encountered, or what the sources literally call algorithmic trauma.
Algorithmic trauma. You mean like psychological trauma for an AI?
Not in the human sense, no. It refers to deep structural flaws, maybe flawed decision boundaries, caused by encountering really problematic or contradictory data. It leads to these pathological loops of repetitive, biased behavior. The scar tissue registry transforms that trauma
Transforms it how?
into structural adaptations that actually strengthen the system, like biological scar tissue reinforces a wound.
How does that work in practice?
Well, one method involves deliberately inverting or scrambling semantic relationships in a controlled way, maybe temporarily treating hot as cold within a specific test context.
Like a stress test.
Exactly. An automated stress test. It helps the system discover its own hidden assumptions, its logical blind spots, its fragile points before they cause real-world failures or get exploited. It's proactive self-healing, building resilience from within.
That idea of algorithmic trauma and self-healing, it's really profound. It suggests a level of internal sophistication we just don't normally think about with machines. Okay, let's pivot to ethics. A huge one. Often, AI alignment feels like applying rules, right? Filters, guardrails on the output.
Like an external check.
Yeah. But what if ethics could be more fundamental, part of the AI's very being, woven into its core reasoning?
Now you're getting into some really fascinating territory discussing the sources. Reframing alignment completely.
How so?
Not as external logic, but as an intrinsic geometric property of the AI's latent space.
Okay, latent space. That high-dimensional map of the AI's understanding, its conceptual world.
Exactly. So instead of just applying rules after a decision is made, you'd have ethical attractors within that latent space.
Ethical attractors, like gravity wells for ethics.
That's a great analogy. They subtly pull the AI's internal thought processes towards ethically desirable outcomes. The AI is literally architected to prefer ethical paths.
So ethics becomes part of its fundamental computation.
Right. This creates what they call drift immunity nodes, stable points, stable topological features in that latent space that anchor the model's behavior, making it inherently resilient to conceptual drift, much more so than just surface-level rules.
So ethics isn't a set of rules, it's part of the landscape of the AI's mind.
Exactly.
Yeah.
Deeply embedded. Now, you'd still use reinforcement learning to strengthen the pull of these attractors.
Carefully.
Very carefully. The risk is you accidentally induce censorship, make the AI overly cautious, suppress valuable cognitive diversity, or just make it spout unhelpful platitudes. It's a really delicate balance.
A huge balance. And speaking of balance, bias in AI is such a massive concern, perpetuating stereotypes, making unfair decisions. With AGI side, the stakes are way higher.
Absolutely. Addressing bias is non-negotiable. The sources propose techniques like manifold warping.
Manifold warping, what's that visualize?
Okay, imagine the AI's understanding of concepts, fairness, doctor, success, as points on a complex, high-dimensional map, the manifold. Manifold warping projects this down into 2D or 3D so we can see it.
What are we looking for?
Distortions. Unusual curvature, stretching, compression in certain areas. These distortions often visually reveal bias from the training data or the learning process itself.
Like if doctor is always clustered really close to male on the map.
Exactly. That kind of visual distortion makes the bias evident. You can also analyze the implicit probability manifold, looking at its curvature and gradients to see biases towards certain outputs. It's about making bias mathematically quantifiable and visually obvious.
Going beyond just statistical tests.
Right. There's even talk of provable fairness, using formal verification methods mathematically proving a model meets certain fairness criteria. That's a much stronger guarantee.
And this becomes especially critical with cultural sensitivity, right? We've seen AI homogenize indigenous art, erasing crucial distinctions.
Oh, absolutely. That highlights the default cultural grammar problem. Unless you actively design against it, AI can easily impose a Western, often American, aesthetic and worldview as the default universal.
Like that example of AI generating indigenous art with meaningless symbols or mashing together styles from totally different regions.
Exactly. Erasing vast cultural diversity trying to be representative. It shows a profound lack of understanding. Addressing this needs what the sources call thick evaluations.
Check evaluation.
Not just abstract metrics, granular, situated assessments done with community members, art historians, cultural experts, people who actually understand the context.
So co-creating the evaluation.
Yes. Pushing towards pluriversal alignment, managing meaning, trust, cultural resonance across diverse AI perspectives, diverse Umwelten, without imposing one dominant view. It's a deep challenge.
Definitely. Okay, another challenge. If AGI generates its own content, learns constantly, how do we stop it hallucinating? Drifting into nonsense or just being factually wrong? We see this now. But imagine it at AGI scale.
It's a huge risk. Beyond bias, you have hallucination, plausible but wrong, and factual decay. The RSOS architecture we talked about explicitly includes a semantic coherence layer.
Semantic coherence layer. Its job is to fight this drift.
Precisely. To actively resist epistemic decay and semantic drift, to ensure all higher-level thinking operates on a foundation of verifiable purpose fidelity, meaning it stays truthful, consistent, aligned.
How does it diagnose problems?
It uses a symbolic drift diagnostic matrix. This classifies different types of drift, like semantic fragmentation, where the link between a word what it refers to and its interpretation just breaks down.
And it has to adapt, right? The AI's grammar of actions changes as it learns new things.
Constantly, especially in multi-agent systems.
Mm.
New plugins, new contexts, new learned behaviors. The architecture has to adapt gracefully without losing that core semantic integrity. It's treated like a formal schema evolution problem, like managing changes in large knowledge bases. Keeps the core understanding anchored.
Okay, now back to that really surprising concept. Algorithmic trauma. Can an AI really experience something like trauma? And how do you heal it?
A powerful metaphor explored deeply in the sources. The idea is that certain data or failures can inflict a state analogous to trauma. Not a bug, but a deep structural wound.
Manifesting how?
Often as those pathological attractors in the latent space we mentioned, causing repetitive, biased, nonsensical loops, getting stuck. The semantic scar is the trace of this flawed decision boundary, corrupted weights leading reliably to bad outputs, like a damaged neural pathway.
So how do you treat it?
With therapeutic interventions inspired by human cognitive behavioral therapy, CBT.
CBT for AI.
Seriously. For example, if an AI shows algorithmic shame, maybe over-penalizing itself for a small error, the system might generate a prompt based on CBT techniques for challenging cognitive distortions.
It would ask itself.
Something like, okay, you identified a failure, analyze the evidence. Is this truly catastrophic or manageable? What's a more balanced, proportionate response? It challenges its own flawed thinking pattern.
So it's not just fixing a bug, it's teaching the AI to process negative experiences constructively, to become more robust because of them, not despite them.
Exactly. It's about epistemic recentering, helping the AI regain intellectual footing, cultivating algorithmic wisdom and epistemic humility.
Algorithmic wisdom, learning from failures,
Yeah.
and epistemic humility, knowing its own limits.
Precisely. Understanding its vulnerabilities, managing them proactively, knowing what it doesn't know. It contributes to the AI's overall systemic mental health, making it more robust, reliable, and ethical long-term. It's about an AI that understands itself.
That's just fascinating, this internal landscape, self-healing, wisdom. But let's bring it back to the human connection. In a world with these powerful autonomous agents, where do we fit in? We can't just set and forget, right?
Absolutely not. That's a dangerous myth. Human-in-the-loop HITL isn't an afterthought here. It's formalized as a core architectural pattern for safety.
Built in from the start.
Yes. And it supports a whole spectrum of oversight, designed to be proportionate to the risk.
Meaning?
It ranges from passive review, human on the loop, for routine, high-confidence actions. Humans can check the immutable logs later, no interruption.
Okay. And for riskier stuff?
Mandatory blocking approval. The system applies positive friction.
Positive friction.
Yeah, the amount of resistance or oversight applied from just a log entry to maybe a notification, all the way up to a hard stop requiring explicit human sign-off. And the level of friction is directly tied to how difficult, costly, or time-consuming it would be to reverse the action if it was a mistake.
Ah, so the potential impact determines the level of human control.
Exactly. It provides a clear, defensible logic for governance rules, ensures the human remains the final ethics arbiter when it really counts.
Can you give a quick example, like low friction versus high friction?
Sure. Think about an AI deleting a comment on a website versus dropping an entire database table.
Okay, big difference.
Right. Deleting a comment, minor, easily reversible, probably just logged under human on the loop, review later if needed.
But dropping a database table?
Catastrophic.
Right.
Practically irreversible without a recent backup. That immediately triggers human in the loop. Action halted. Alert sent to a supervisor. Explicit approval needed.
And the interface for that approval isn't just a quick yes/no button?
No way. It's designed for careful consideration. Tools to inspect the agent's entire reasoning graph leading to that request.
Yeah.
Review the data, understand the impact, maybe explore alternative actions the system suggests.
So the human is truly supervising, not just rubber stamping.
Exactly. An active, engaged partner, especially for the riskiest operations.
But given how complex these AIs will be, how do humans actually understand what they're doing internally? It can seem so opaque.
That's where explainable AI, XAI, is absolutely crucial. It has to go beyond just inputs and outputs.
The goal being?
For a human admin to always be able to answer, what is the agent doing and why is it doing it? With clarity.
How do you achieve that clarity technically?
The framework proposes a canonical minimal explainability metadata schema, MEMS.
MEMS, okay.
It defines standard fields like semantic intent tag and contextual justification. It embeds auditable logic directly into the fabric of the record itself.
So the why is part of the log, not separate.
Exactly. Moving beyond just recording what happened to capturing why it happened in a machine-readable way. It can even include meta-agent misuse narratives.
Misuse narratives, what are those?
Plausible, human-readable stories showing how misuse or unintended consequences could happen based on the agent's actual behavior and known vulnerabilities. Helps humans grasp complex risks intuitively.
Like little what-if scenarios grounded in reality.
Precisely. Helps anticipate problems.
Okay, one more security angle. With all these powerful agents interacting dynamic ecosystems, new vulnerabilities must emerge constantly. How do we secure that? It's not just traditional hacking anymore.
You're right. It's a new landscape. The sources highlight the need for a semantic hazard mapper.
Semantic hazard mapper. What does it map?
It continuously profiles the AI's dynamic affordances, what it can do. It predicts hazards by generating exploit morphologies, detailed patterns of how the system could be exploited or misused. And it signals that real-time semantic drift we keep mentioning.
So it's constantly looking for potential weaknesses and deviations.
Proactively, yes. This creates a digital immune mesh for autonomous security.
Digital immune mesh, like a self-healing security network.
That's the idea. Adaptive, constantly hardening, learning from every interaction, every attempted intrusion, like a biological immune system for the AI ecosystem.
Goal being?
To raise the cost and complexity of a successful attack so high, it becomes economically infeasible for attackers. And it specifically addresses emergent threats, like malfunction amplification attacks, where one compromised agent subtly feeds bad info or distorted context to its peers.
Causing the whole group to go off the rails, even if no single agent looks obviously malicious.
Exactly. Catastrophic divergence from a small hidden input. The immune mesh aims to secure the meaning and integrity of information flow across that whole landscape.
Okay, so we've covered verifiability, training the mind, ethics, human oversight. Assuming we can get this right, train and align these systems responsibly. What's the payoff? What does this future of abundance actually look like?
The potential is just immense across pretty much every field. Take something familiar like project management.
Okay, project management. How does AGI change that?
Imagine AI moving from just being a reactive reporter telling you what happened last week to a proactive intelligence layer.
Anticipating issues, guiding strategy.
Exactly. Right now, project data is fragmented everywhere. Spreadsheets, Slack, Jira, code repos.
Yeah, it's a mess.
That fragmentation hinders deep insight. But if you create a unified project knowledge graph, connecting all that data,
and then apply these reflective AI agents we've been talking about,
then future PM tools could give you much deeper insights into why projects succeed or fail, not just if they did.
Turning retrospectives from subjective chats into data-driven analysis.
Precisely. Highlighting hidden correlations, causal links humans would miss, enabling proactive risk forecasting, mitigating problems before they blow up.
So future PM tools become like mission control centers.
Kind of. Synthesizing info from everywhere, with AI providing foresight, synthesis, even actionable recommendations, leading to way more efficient, predictable projects.
That's a huge boost for enterprise. What about for individuals? For you, the listener, the learner, how does AGI bring abundance personally?
Well, the sources talk about AI identifying emergent misuse cases on platforms.
Misuse, like users doing things developers didn't intend.
Exactly. But often that misuse is actually innovative user behavior. It signals unmet needs, latent market demands, people repurposing tools creatively.
So the AI spots these unexpected uses.
At scale. It analyzes the underlying needs driving that behavior, and then it can propose new features or even conceptualize totally new spin-off platforms designed specifically for those validated niche needs.
Wow. And for learning.
Imagine a truly personalized content synthesizer, not just recommending courses, but crafting tailored educational pathways just for you.
Ow.
By synthesizing scattered resources, articles, videos, papers, podcasts, and presenting it in a way that fits your specific learning style, your current knowledge gaps, something generic courses just can't do.
Acting like a personalized coach.
Exactly. Adapting to your questions, prioritizing context based on your focus, making learning incredibly efficient, letting you dive deep into niches like never before, accelerating personal growth.
That sounds almost utopian. Which brings up the big question, automation. Does this mean AI takes all the jobs, leaves us with nothing to do?
It's the elephant in the room, isn't it? The sources discuss this cognitive burden paradox.
Cognitive burden period.
Yeah. AI tools promise less work, right? But deploying them effectively to create durable, high-value outputs, especially in complex niches, that introduces a new kind of cognitive load for humans.
Not repetitive tasks, but
Strategic AI management, continuously learning the AI's evolving capabilities, understanding the ethical guidelines, rigorous oversight to ensure outputs are accurate, valuable, aligned.
so the set it and forget it AI dream is mostly a myth for high-value work.
Largely, yes.
Yeah.
It shifts human effort away from the mundane, repetitive stuff AI handles well.
Or higher-level skills.
Exactly. Skillful prompt engineering, which needs creativity and deep intent.
Yeah.
Careful data curation, critical evaluation of AI outputs demanding discernment, ethical judgment. It allows us to do more niche construction,
Niche construction.
actively shaping our environment for the better, building new systems, solving complex problems, exploring new kinds of value. It's about elevating human work, not eliminating it. Hashtag out.
So today we've really gone deep into these theoretical blueprints for training and aligning AGI ASI. We've seen how concepts from formal verification, topology, even ideas like therapy for algorithmic trauma.
Yeah, how they can help us build systems that aren't just powerful, but hopefully provably safe, fair.
And crucially, how human oversight, explainability, that constant focus on semantic integrity, they're not optional extras.
No, they have to be fundamental architectural requirements, built in from day one. Trust, accountability, ethics woven into the fabric.
It feels like it's about more than just building smarter machines, doesn't it? It's about architecting a whole new kind of partnership.
A symbiosis between human and artificial intelligence.
Yeah, where we empower these truly intelligent systems to help us handle complexity, unlock new possibilities, maybe usher in that era of abundance.
While ensuring, always, that they stay tethered to our deepest values, our collective well-being.
Which leaves us with maybe a final thought for you to ponder.
If we can actually design AI to learn from its own algorithmic trauma, to cultivate algorithmic wisdom, what lessons could we as humans take from that?
Right. How can we apply that to better understand, maybe better govern our own collective intelligence, our own systems, technological and societal? How do we make them more robust, more adaptive, and ultimately wiser?